Let's talk about variables, the most basic way we store information in a program. Think of a variable like a house. In a city, there's lots of open land, but you can't just throw your stuff anywhere and hope it stays safe. You need a house, a structure that can contain and organize your belongings. The same is true in programming. Your computer has a lot of memory, but it's all just raw space. You need a way to label and reserve part of that memory to hold something useful, a number, a name, a status. That's what a variable does. It's like saying, here's an empty house. I'm going to call it my home. Now it's ready to hold something. Maybe I move into it. My home equals Alan, or I store a number in it. Groceries equals 1200. Suddenly, I've gone from raw memory to organized data, from an empty street to a named space with purpose. And just like houses can hold people, families, or even pets, variables can hold different types of data: numbers, text, booleans, lists. As our robot gets smarter and starts doing more things, we'll need more of these houses, not just to store values, but to organize them into neighborhoods, blocks, even buildings. That's where data structures come in. But it all starts with a single variable, your first tiny house in the vast memory of the machine. As my robot got smarter, it needed to remember more than just single pieces of data. Let's say the robot has to deliver groceries to 5 houses. If I store each delivery as a separate variable, like house 1, house 2, house 3, it quickly gets messy. Hard to manage, easy to mess up. So instead, I use a list, an ordered collection. Now I can store all deliveries in one place. Deliveries equals milk, bread, rice, fruit, soap. And if I want to know who the delivery is for, I use a map or dictionary, a collection of key value pairs. Deliveries equals Alan and milk, Priya and eggs, Jew and rice. Simple, clean, organized. Now imagine our robot is promoted. It's managing an entire team of robots. One robot manages 3 others. Each of those manages 2 more. What kind of structure do we use? We use a tree. Trees help represent hierarchical relationships like company org charts, file systems, menus in apps, or comment threads on social media. And then we have stacks and queues, special types of lists that follow rules. A stack is like a stack of plates, last in, first out. A queue is like a line at the grocery store, first in, first out. As programs grow, organizing data becomes just as important as writing logic. If your data is a mess, your code will struggle, no matter how well you write it. This is where smart software design begins, in how you shape, structure, and access your data.